Welcome to the DIY Honda Garage channel. Diagnostic Trouble Code DTC P0502 indicates a specific issue related to the continuously variable transmission CVT speed sensor circuit. This error highlights an open or short circuit condition within the sensor's electrical system. The CVT speed sensor is crucial for monitoring the transmission's performance by providing real-time data that the Powertrain Control Module, PCM, uses to optimize shifting and engine performance. The sensor is typically located near the transmission assembly. Troubleshooting this DTC is important for maintaining proper vehicle function, as a malfunctioning speed sensor can lead to transmission issues or degraded performance, ultimately affecting drivability. The DTC P0502 indicates that there is an issue in the CVT speed sensor's electrical circuit. It is essential to note that this error cannot be caused by mechanical problems within the transmission itself, which rules out any physical damage or malfunctions of the transmission components. The CVT speed sensor plays a vital role in gathering data regarding the vehicle's speed and relaying this information to the PCM. Essentially, the sensor helps to ensure the smooth operation of the transmission system by providing accurate data that assists in shifting operations. When a circuit error, such as an open or short, occurs, the system cannot receive the necessary input, which leads to this DTC being triggered. Several factors could lead to the occurrence of DTC P0502. First, electrical circuit issues are commonly at fault, which might stem from bad connections or faulty wiring. Next, the defective CVT speed sensor can also trigger this DTC. If the sensor itself malfunctions or fails, it can lead to improper data transmission to the PCM. Additionally, damaged wiring or connectors can create inconsistencies in the signal flow, impacting the entire system's functionality. It's vital to thoroughly investigate these areas to isolate the exact problem and take necessary corrective measures. When DTC P0502 is triggered, you may notice several symptoms that can indicate an underlying issue. One common symptom is the illumination of the check engine light on your dashboard, alerting you to potential problems in the vehicle's electronic systems. Additionally, there may be changes in transmission performance, such as slipping or harsh shifting, since the PCM relies on accurate sensor data to manage smooth operation. You might also observe erratic speedometer readings, which can be disconcerting, as this indicates that the sensor is not providing reliable information. Overall, these symptoms can lead to a noticeable decline in vehicle performance and drivability. The first troubleshooting step involves verifying the problem through a series of preliminary checks. Begin by turning the vehicle to the on mode without starting the engine. Then, utilize the Honda Diagnostic System, HDS, to clear any existing DTCs. This step is essential to ensure you are working with fresh data. After clearing the codes, securely raise the vehicle on a lift to allow for further inspections and ensure that the front wheels can rotate freely. Once this is done, start the engine. At this point, entering the Vehicle Stability Assist (VSA) maintenance mode is recommended to test vehicle performance more accurately. Finally, test drive the vehicle in D position, maintaining the engine speed at 1,000 RPM or higher, while observing for any further DTCs that may appear. In this second step, you'll investigate the electrical integrity of the CVT speed sensor circuit. Start by turning the vehicle to off lock mode. Subsequently, disconnect the CVT speed sensor's 3P connector, which serves as the link between the sensor and the rest of the electrical system. With the connector disconnected, turn the vehicle into on mode again. The next crucial action is to measure the voltage between test points that correspond to the sensor's connections. Specifically, you will check the voltage at female terminal number 3 of the CVT speed sensor 3P connector against body ground. An expected reading of around 5 volts would indicate a healthy VCC2 wire. If the voltage is present, proceed to the next steps in troubleshooting. If not, further investigation is required. Step 3 consists of a more specific open wire check focusing on the VCC2 line. First, turn the vehicle to off, lock, mode. To prevent any potential damage to the powertrain control module, PCM, jump the SRS, supplemental restraint system line, using the HDS and wait for more than a minute. Following this precaution, disconnect the PCM connector C, 51P. Next, you'll need to check for continuity between 2 test points: female terminal number 3 of the disconnected CVT speed sensor's 3P connector and pin number 30 of the PCM connector C. Achieving continuity here is critical, as it confirms that the VCC2 wire is functioning correctly. If continuity is established, the wire is okay, and at this point, you may need to research any related service information for further guidance. For this step, you're checking the integrity of the SG2 line within the circuit. Ensure the vehicle is in on mode and the CVT speed sensor's 3P connector is still disconnected. Now, focus on measuring the voltage between 2 specific test points. You will check between female terminal number 2 and terminal number 3 of the CVT speed sensor connector. You're looking for a voltage reading around 5 volts. If you receive this reading, it confirms that the SG2 wire is in good condition, allowing data to transmit effectively. Should the voltage be absent, it's vital to repair any break or fault within the SG2 wire, particularly between the CVT speed sensor and the PCM, to restore proper functionality. This 5th troubleshooting step investigates the integrity of the VEL-DD line for potential shorts. Commence by turning the vehicle to off, lock mode to ensure safety. As with earlier steps, jump the SCS line with the HDS, allowing for a 1-minute wait period to protect the PCM. After performing this precaution, disconnect the PCM connector C, 51P once more. The next task is to check for continuity by comparing 2 test points: female terminal number 1 of the CVT speed sensor connector and the body ground. A continuity reading here indicates that there is an issue, suggesting a short circuit to body ground in the VEL-DD wire, which must be repaired to restore proper operation. If you do not find continuity, this suggests the wire is not shorted, so proceed to the next step. The final troubleshooting step involves an additional open wire check on the VEL-DD line. With the vehicle still in off-lock mode and the CVT speed sensor 3P connector and PCM connector C, 51P disconnected, you'll want to check for continuity again. Specifically, test between female terminal number 1 of the CVT speed sensor connector and pin number 32 of the PCM connector. A continuity result here demonstrates that the VEL-DD wire is functioning correctly. If continuity exists, but the DTC persists, it may indicate that the CVT speed sensor itself is faulty and should be replaced. Conversely, if the continuity test fails, it suggests an open wire that needs to be repaired to restore the circuit's functionality. After completing the diagnostic and repair procedures, it is crucial to conduct a final verification to ensure everything is functioning correctly. Start by rechecking all electrical connections related to the CVT speed sensor and any pertinent wiring that may have been repaired or replaced. After confirming that everything appears secure, use the Honda Diagnostic System, HDS, to clear all DTCs from the PCM's memory. Finally, it's vital to perform a test drive of the vehicle to verify that it operates without re-triggering the DTC P0502. Observing the vehicle's performance post-repair, is essential in confirming that the troubleshooting process was successful. To prevent reoccurrence of DTC P0502 and to keep your Honda CRV operating smoothly, implement a stringent preventive maintenance regimen. This begins with regular inspections of the vehicle's electrical system, focused review of critical connections, and wiring that may be subject to wear and tear over time. Keeping an eye on connectors for any signs of corrosion or damage is vital, as these components play a fundamental role in ensuring continuous performance. In addition, conducting routine evaluations of the CVT speed sensor and other vital sensor performance will help detect issues before they escalate. Ultimately, a proactive approach can save time and resources, ensuring reliable vehicle operation. In summary, DTC P0502 signals a significant issue with the CVT speed sensor's electrical circuit on the Honda CRV. Understanding the implications of this code is essential for effective troubleshooting. A structured approach, starting from problem verification to detailed checks of the speed sensor and related wiring, is necessary to identify and rectify the underlying issue. Regular maintenance practices can further minimize the risks of encountering similar DTCs in the future. By staying vigilant with vehicle inspections and ensuring the integrity of critical electrical connections, owners can maintain optimal performance and reliability of their vehicles. Please like and subscribe to the channel. See you next time!